Come back. Today I will see the new topic, calculus of variations. This is actually very important for higher study. This is actually applied part. For any competitive exam, this part is very important. At first I will see what is the actual calculus of variations. The calculus of variations is a field of mathematical analysis that uses variations, which are actually small changes in functions of functionals. This is actually small change in function of functional. To find local minimum of the function, we all of us know to find the local minimum of the function, find f prime x or dy dx, and f prime x equal to 0. This is always give the stationary points. Now, for these functions of functionals, solve the equation for these functions of functionals. This is actual idea of calculus of variations. Actually, we have to find the maximum or minimum. Here, functions of functionals. And these functions of functional is denoted as here if. Now let's see this part. What is the functions of functionals? Calculus of variation. Consider this xy plane, and in xy plane consider the point a equal to x1 y1 and b equal to x2 y2. Then find a path such that the distance AB is minimized. That means here I equal to integration a to b ds, which is equal to integration x1 to x2 square root of dx square plus dy square times dx, which is equal to integration x1 to x2 square root of 1 plus dy dx whole square times dx. Now find y equal to fx between the point a and b. Between the point a and b means this point a and b, such that the integral I equal to integration x1 to x2 square root of 1 plus dy dx whole square dx is minimized. This is actually the functions of functionals. Here this is the functional. If you use one function, then you will use this indefinite integral, and if you use the another function, then you will get another indefinite integral. Here the function is such type y goes to iy. Okay. For different function, you will get different indefinite integral. This definite integral, which is denoted as iy, equal to integration x1 to x2 f of x comma y comma dy dx times dx, and this is actually is a well defined quantity. When the integrand f is given as a function of x, y and dy dx, when y is a given function of x. Third, this is actually number when these x1 and x2 have definite numerical value, and the different choice of y as a function of x are substituted in this integral, and we want to find the particular functions y equal to yx that gives the maximum or minimum value. Okay, This is actually idea of calculus of variations. What we want is to find the particular function y equal to yx that gives to 1 its minimum or maximum value. In calculus of variation, actually we will discuss this kind of problem in details, and this include the problem of actually the shortest distance between 2 points on given surface, the quickest distance between 2 points, and the surface of revolution of minimum area. This is actually the main goal of the calculus of variations. We study actually the method for the solving a variety of variational problem, and discuss some functional which are mainly appeared in applications and investigation for extrema, which is equal to integration x1 x to x2 f of x y prime x dx. This is one type. Another, it can be integration x1 to x2 f of x y prime x up to yn x dx, or it can be integration x1 to x2 f of x y1 x up to yn x comma y prime x yn prime x dx, or it can be double integration f of x y z of x y del z del x del z del y dx dy, in which the functions f are given while the functions yx y1x ynx zxy are arguments of functions. Are iyx equal to integration x1 to x2 f of x y1 dx with respect to the initial condition y x1 equal to y1 and y x2 equal to y2, and this integrand is actually function of function. That means this is actually functional, because this part x y dash also be function. If a functional iyx attains a maximum or minimum on the curve y equal to yx with respect to all curves y equal to yx, then this is called the extremal. That means here the extremal means either it is maximum or it is minimum, and the value of maximum or minimum is called extremum value. Actually, this is the value of this integration. This value of the integration is called extremum value, and Euler equation is necessary condition to extremize the equation. Okay, now I will see what is the Euler equation to extremize the equation. Necessary condition for this integration to be extremum is that first Euler equation is del f del y minus ddx of del f del y dash equal to 0. Second Euler equation is ddx f minus y dash del f del y dash minus del f del x equal to 0. The function is higher variable, means here when here represent y double dash, then del f del y minus ddx of del f del y dash plus d2 dx2 del f del y dash equal to 0. Now let's see some example of calculus of variation. First example, very interesting. Here function of functionals is xy plus y square minus 2y square y dash dx, and the boundary condition is y0 equal to 1 and y1 equal to 2. Here f of x comma y dash equal to xy plus y square minus 2y square y dash. Now I will use the Euler's formula, del f del y minus d dx del f del y dash equal to 0. Here del f del y means obviously x plus 2y minus 4y y dash minus d dx of del f del y dash means 2y square. Now this would be x plus 2y minus 4y y dash minus 4y y dash for plus equal to 0. Just omit this part, then this would be x plus 2y equal to 0. That means y equal to minus x over 2. Here y equal to minus x over 2. That imply obviously y0 equal to 0. But here given the boundary condition y0 equal to 1. That means this functional y equal to minus x over 2. This does not satisfy the boundary condition. So obviously this functional has satisfied the Euler equation, but this functional since does not satisfy the boundary value problem, so this functional does not have any extremal. Okay, so I have told you any functional may does not have always a solution. I hope my all viewers have understood this is clearly. Okay, well. Next example, integration x0 to x1 y square plus y dash square minus 2y sin x dx. Here f of does not have any boundary condition for arbitrary condition for all boundary solution. Here the Euler equation is del f del y minus d dx of del f del y dash equal to 0. Del f del y means obviously 2y minus 2 sin x. d dx of del f del y dash means 2y dash. Then that imply 2y minus 2 sin x minus 2y double dash equal to 0. That imply just common 2. Then that imply 2 times y minus sin x minus y double dash equal to 0. That imply y minus y double dash equal to sin x. And from this expression this imply y double dash minus y equal to minus sin x. Then that imply d square minus 1 y equal to minus sin x. That means that imply m square minus 1 equal to 0. That imply m equal to plus minus 1. The complementary equation is c1 e to the power x plus c2 e to the power minus x. And particular equation is 1 over d square minus 1 minus sin x. And we all of us know for this particular equation here we have to put d square equal to minus 1. Then this value would be 1 over minus half sin x. That means yx equal to c1 e to the power x plus c2 e to the power minus x minus sin x over 2. This is the solution of this functional. That means this is actually the extremal solution. That means this is the minimal curve of this functional. Okay. Oh well. Now I will see one example which had come CSIR NET June 2023 exam. If you know the before problem, then you will solve this question easily. The question is here the functional is integration 0 to 1 y dash whole square minus y dash plus xy dx with the boundary condition y0 equal to 0 and y1 equal to 0. Then which of the following statement is correct? Option 1, yx has no stationary functional. Option 2, y equal to 0 only stationary functional. Option 3, yx has unique stationary functional and y is not identically equal to 0. Option 4, yx has infinitely many stationary functional. I hope my all viewers have understood this question easily. Now let's see the solution. At first try to own cell, then see my solution. Functional is y dash square minus y square y dash plus xy. Just use the Euler equation, del f del y minus ddx of del f del y dash equal to 0. Then this would be minus 2y y dash plus x minus ddx of del f del y dash means 2y dash minus y square equal to 0. Then after differentiating, this value would be minus 2y y dash plus x minus 2y double dash plus 2y y dash equal to 0. By this expression, this imply y double dash equal to x over 2. Then after integrating, this value would be y dash equal to x square over 4 plus c1. Then y equal to x cube over 12 plus c1x plus c2. Now using the boundary condition y0 equal to 0 and y1 equal to 0, using this boundary condition, this value would be, first boundary condition is y0 equal to 0. After putting this value would be c2 equal to 0. Second boundary condition is y1 equal to 0. Then this value would be 1 over 12 plus c1, since c2 equal to 0 plus c1 equal to 0, that implies c1 equal to minus 1 over 2. That imply yx equal to x cube over 12 minus x over 12. This is the extremal of this functional. Now let's see the solution. First, it has no stationary functional. This is wrong option. Y equal to 0 only the stationary functional. This is wrong option. It has unique stationary functional. Y that is not identically equal to 0. This is right option. It has infinitely many stationary functional. This is wrong option because here I have got unique value of c1, c2. So only true option is unique stationary functional. Okay? Oh well. Today I will stop here. In my next video I will discuss this type of question again, because this type of question actually very important for higher study. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.